All right, so now that we are comfortable solving trig equations with basic situations, we're now going to start replacing with the different identities that we use in our second unit. So here we're solving over the interval 0 to 360 only because we are now mixing trig functions. We can't talk about principal values. Tangent and secant have different principal values, so depending on which function you replace, you might get different principal values at the end. So now we're going to focus in on our 0 to 360 range. That range of numbers could change just like we did with graphing. So if you get a different range of numbers, let's say negative 180 to 180, you could solve it 0 to 360 and then just get coterminal angles to get your angles in that situation. So just something to keep in mind, although we're working with 0 to 360 to start with. All right, first thing you want to do is think about what identity connects tangent and secant. Now, could you change this into sines and cosines? Most likely, yes, you could do that. I want to think about our identity of tangent squared plus 1 is secant squared. And I want to rearrange that because I actually want to be replacing the tangent squared. So I would need to make this tangent squared is equal to secant squared minus 1. So just like we did in the identities unit, we can use the identities, rearrange them. So not only is this unit great because you get to pull back out your unit circle, but you also get to pull back your identity sheet and kind of combine both of those topics together. So I'm going to replace tangent squared with secant squared minus 1. And then we still have the plus secant equals 1. Your goal here is to get it all in terms of one trig function. Now some people might at this point switch it over to all in cosines, which might be easier. I'm going to show another option, but down the line you might want to put it in terms of cosine because eventually you're going to anyway. So the only extra thing I'm going to do here is subtract the 1 from both sides because it is quadratic. Put it in descending order. And then something you can do, pull it off to the side, is pick a variable. I'm going to use m for today, but it really doesn't matter what variable, and do m instead of secant. You could use a. I wouldn't use x. I would use something different since we're using x as our variable, unless you're using theta in there. And then we're going to factor. So a lot of factoring or quadratic formula work you're going to be doing here. This would factor into m plus 2, m minus 1. So not a terrible factoring situation. And that really would mean secant plus 2 times secant minus 1. So you want to show that in your step. Set each of those equal to 0 like you would normally do with a factoring problem. Solve it. Oops. Now, in this situation, it's not terrible to have secant at the end. If you had to do this with quadratic formula, I would recommend switching it over to cosine to start with, because here we have to take the reciprocal. It's very easy to take the reciprocal in the problem where you have nice values. So in, reciprocal of negative 2 is negative 1/2, and reciprocal of 1 is just 1. Let's say you did have a quadratic formula situation. It would be much easier to get the function in terms of cosine and then plug in the quadratic formula there instead of waiting till the end. Okay, so since we're going 0 to 360, you want to think reference angles. Reference angle for inverse cosine of 1/2 is 60 degrees. And then cosine is negative in the second and third quadrant. So we would do 180 minus 60. That's going to give us 120 for the second quadrant. And we're going to do 180 plus 60 for the third quadrant. Remember, we're going backwards of the rules. So second quadrant is kind of the same as the original rule, but when you go to third quadrant, you're adding instead of doing the angle minus 180. And then the inverse cosine of 1 is just 0 degrees. And that only happens once. So I'm going to put the 0 degrees here and just box all those off together. This would be a good time to check. Now, we have some different options for checking. So far, we were just plugging it in the calculator, but we're going to do a second step with this and check it with our calculator and kind of show what we would do with our calculator for that. So this video is already at 5 minutes. I'm going to stop here, but we're going to use the same equation to check it with the calculator in your second video.